All right, great. Good morning, everyone. My name is Jan Smolders. I'm the Chief Commercial Officer at Space Inventor, and I'm going to talk today about vertical integration, not just any vertical integration, we call it deep vertical integration. What is it, and what is actually the value? First, quickly, one slide about us for those who are not familiar with Space Inventor. So we're a company based in Denmark, we're a satellite manufacturer, and we're also a satellite equipment provider. We've launched our first satellite back in 2018, and since then we've been growing the size of our bus with more skills, more capabilities, serving Earth observation, space situational awareness, or communication satellites for either government or commercial or military applications. We've launched the first 16 new into GEO about 1.5 years ago. That was a milestone. We're going to launch 2 more of those very soon. Very exciting. And we're also launching our first microsatellite next year as well. So exciting times ahead for us. Now, about the topic of today. So satellite manufacturing and vertical integration is often related to the make or buy decision. Every conference like this will have a panel discussion or a presentation about the make or buy. Okay, so what's our perspective on it? On the one hand, you have your make, your in-house manufacturing. In-house manufacturing can lead to direct control on your production processes, obviously. It can eliminate reliance on suppliers, and sometimes there are significant markups. And also it allows to optimize materials and resources across the full production chain, the full value chain. On the other hand, you have outsourcing, right? So outsourcing can lead to higher costs actually for low volume, let's say, components. Often it's related to lowering cost, but that's really for high volume when you talk about automotive industry, but that's not the same in aerospace or in satellite manufacturing. It's not about thousands and thousands of components, it's about a couple of dozens or hundreds, right? Increased vulnerability. We've all experienced COVID, post-COVID, supply chain disruptions. And finally, less control over quality and delivery times. So, vertical integration, deep? How deep? What does that mean? We say we break free from machine shops, okay? So, we have been insourcing CNC machining and PCB assembly. So we have a fully operational SMT line since about a year. And in addition to that, we just became the proud owner of a 5-axis CNC machine that we're playing around with and getting operational as well. And on top of that, obviously, we also have all of the component testing equipment in-house to immediately test what comes out of these machines. So, with that deep vertical, what does that bring? Time savings. First of all, reduced lead times. When we order a batch of, let's say, housings for a reaction wheel or an OBC, it can take 4 to 6 weeks. All right, we're reducing that to a couple of hours. Okay, that's weeks to hours. Secondly, efficient communication. Basically, we click print, just like you would print a document on your printer in the office. Basically, the engineer can click print, and the component, so to speak, rolls out of the machine in the basement. And thirdly, embracing Industry 4.0, what also Delphine was talking about. Really working out of the same ERP system. You don't need to have shared folders with data that is out of date. You can just work with the right model at the right time out of your ERP system. Second one is quality, control on quality. Also, we had to, ship back like 50 components that were delivered and were faulty. We don't have to do that anymore. First of all, we can build standardized processes because we have just better control over the whole chain. Secondly, we can do immediate component testing. Any component that comes out of the machine, we can immediately test that, right? And thirdly, continuous improvement. By having that manufacturing skill in-house with those dedicated people, we can actually together keep on improving those processes. And then engineering design cycles. This is probably the most underestimated value of deep vertical integration. It's about rapid prototyping, okay? As I said, we click print, we can make a PCB, we can make a housing, we can put that together, we can go down to our testing facilities, we can test that, we can get the results, and then immediately we can inspect those results and make a better design and print a new one. And that basically could be done in a day, all right? And that's really I think this one is really feeding one of the core DNAs at Space Inventor, and that's curiosity. We're curious, we want to push the boundaries, we want to do innovate, try new things, and now we have all the skills and equipment in the house to be very fast on this. Now let's look at some numbers. We're all, a lot of us are engineers here, we like to see numbers, so I put a few numbers on the slide. First of all, 90% reduced lead times. I mentioned earlier, weeks to hours, not 4 weeks, 6 weeks, a couple of hours, and we have a couple of, let's say, mechanical housings rolling out of the machine. 25% lower inventory cost by efficient production planning, by basically not having to deal with minimum order quantities, by not having to deal with obsolete stocks of a couple of housings that because we changed the design, that we're stuck with 50 housings that we ordered last week. None of that. So we can reduce inventory costs and we can reduce scrap rate. It happened to us as well. We order 100 housings, maybe 20 or 30 of them are faulty. So what do? We scrap them, we ship them back. I don't know. We don't have to do that because we can immediately test that component once it's manufactured. Finally, increased agility and responsiveness to market demands. 3 points. Turnaround times. Today, we are building manufacturing equipment within about 2 to 3 months. Whether it's an onboard computer, a reaction wheel, batteries, you name it. About 3 months. Satellites, 6 to 9 months. We want to get that down. The market is expecting that to get down. So we want to get that down for 1 month for equipment and less than 6 months for satellites. That can only be done when we have that control, when we have those skills, when we have that equipment in-house. Secondly, adaptable manufacturing. It happens often that you sign a contract with a customer. That customer brings a payload, and after 2-3 months in the project, the customer says, well, we actually have a new version of the payload. It has a different interface, different power requirements. Would we be able to host that new version of our payload? That would be really nice. Previously, we'd have to say, well, it will take 3 months at least to order new housings because it has to fit the new interface or whatever. And so it would not be possible. Now we can make that possible, okay? We can iterate fast in a couple of days. We can try new ideas, have a new prototype, and actually try to host that changing requirement on our satellite. And thirdly is faster innovation. Because we can look at what's happening in the market, changing market trends, changing quality standards, and then try them in-house, right? If we see something changing, we can change also our products and get them up to spec. To conclude, basically these, let's say, main strengths as I talked about today: agile response, changing, let's say, supporting changing market demands, enhanced reliability, tighter control on the process, enhanced innovation because we have production and engineering sitting together in the same office, in the same meeting room. Increased profitability. I actually didn't talk a lot about costs because cost is not really the main driver here. It's really about quality and lead time and control and engineering. But obviously there will be reduced costs that we can then reinvent into innovation. And we believe all of that is kind of bringing us a competitive edge into the market of satellite manufacturing. So that's my presentation for today.